So good day once again. My name is Graphics. Today we're looking at dryness fraction. We say a dryness fraction can be defined as the amount of dry steam present in total amount of wet steam. It has no unit and it is represented by x, small letter x. Or you can say the dryness fraction is defined as the mass of saturated vapor present in 1 kilogram of the mixture. What's the mixture? Wet steam. Now let's take, for instance, if I have this way, and I have my dome like this is what we call it, dome, right? We know this point here is for my liquid, it's also given as F, and here is for my vapor, it's given as what? G. And inside there will give you as my what? My Fg, both liquid and vapor. The only way we can calculate our dryness fraction is only within this dome. We'll calculate our dryness fraction. But outside this dome here, we know it is pure liquid. Our dryness fraction outside this dome is equal to what? 0. Because there's no element or trace or dryness at this part of the dome. But at this part here, at the liquid, our dryness fraction is equal to what? To 1. So our dryness fraction is only calculated within this zone to look for what? It's also called quality. Are we good? So when we are told to mathematically, we say our dryness fraction is equal to what? The mass of the gas or the vapor all over what? The mass, the total mass. Right? And what is our total mass? Our total mass is what? The mass of the liquid and vapor existing. That's what? The mass of gas plus the mass of what? Of vapor, of gas, of liquid. So hence we will now say my x is equal to what? My mass of gas over what? Mass of gas plus what? Mass of vapor. So this is our what? Our dryness fraction. Are we good? So on a nutshell, we can easily say that the dryness fraction of any substance mathematically is given to be this. Now one thing you also need to know is that what you need to know is that when we are given volume, and maybe we are given our volume and we want to calculate our specific volume, just like I said earlier. So we know that our volume is equal to what? Specific volume multiplied by what? Mass. So if it is for the fluid, the volume of the fluid, this will be the specific volume of the fluid. Right? This is automatically we say my specific volume is equal to what? My volume over what? MF. We'll call this F here. This is one point you need to know. Right? It comes in any form. I also need to know that what? My total temperature is equal to what? My sensible heat. My total heat is equal to sensible heat plus what? Latent heat. Are we good? So also we should also know that my mass of what? The mixture is equal to what? The mass of what? The liquid plus the mass of gas. It's another relationship again. And also we need to know that V, the volume, is equal to what? The volume of the liquid plus the volume of gas. Are we good? So when we have from equation, let me call this to be my, when we have V is equal to what? Specific volume is equal to our volume, so over M. So we can easily say that my V is equal to VF plus VG all over M, right? It's another relationship here. Are we good? So if you decide to use this guy, we know VF is equal to VF MF. Also, VG is equal to what? VG mg. This is the volume of the gas and the specific volume of gas, and this is the mass of the gas too. So if I substitute these two values in this equation here, so my V here will be equals to, so I'm writing VF, I'll write VF MF plus, and I'm writing VG, I write what? VG mg. Everything over what? Over mass. So we should know this also. So where mg is what? Mass of gas, then Vg, this small v, that is the intensive form, is equals to what? Specific volume of gas. And we have the bigger V, which is in extensive form, that will be the volume of gas. And we have VF, which is giving us the small v, the specific volume of liquid. Then we have big VF, which is in excessive form, which is giving us the specific volume of, this is of the volume of liquid, the volume of liquid, so on and so forth. Thank you very much.